In this lesson, we're going to be discussing casting. Casting allows us to change one primitive type into another primitive type. Our lesson objectives: learn how to change a variable's variable type and learn how to do proper division in Java. So let's first convert an integer into a double. So I declare an integer and assign the value 420. Integer favorite integer is equal to 420. 420 is an integer because it has no decimal point. Now I want to assign this integer to a double. So I do double favorite double is equal to, and in parentheses I write double and then I put the variable name that I want to change. This tells the compiler that whatever is coming after our casting sort of sequence, we want to convert that into a double. So favorite integer, which is a integer and is the number 420, now becomes 420.0, and 420.0 is then assigned into favorite double, so that when we print out favorite double, it is equal to 420.0. Now this is what you call widening casting, because we're converting an integer to a double. When you think about it, there are more doubles rather. You could say, if there are an infinite amount of numbers. However, doubles allow us to be more specific with our numbers. So although 420 is the exact same thing as 420.0, the computer adds that 0.0 to emphasize that it's a double. So that is why it's called a widening casting. That's why it's widening casting. However, if you want to convert a double to an integer, you have to do something called narrow casting. And this is a very different process, because although widening casting can be automatically done by the compiler, this you have to specifically utilize casting. So I declare a variable called nice, and it's a double, and I assign the value 6.9. 6.9 is a double because of that decimal point. Now I want to assign 6.9 into integer not nice, but you know that you cannot assign a double into an integer without losing some type of data. That's why it's called downcasting, because we are technically losing some type of data. So when we use our casting sequence, open parentheses, integer, close parentheses, nice, that tells the compiler that whatever the value of nice is, we want the compiler to cut off anything past the decimal point. That way, when we print out not nice, it prints out 6. It does not print out the rounded answer. It does not print out 7. Just because it's 6.5, just because it's 6.7 doesn't mean it's going to print out 7. It's going to print out 6 because it cuts it off. Now, if you remember with our division from our arithmetic operator video, one of the problems that we came across was that when we were dividing integers, right, and we know from our math class that when we divide integers, we can get a double. However, when we were dividing integers, we were only getting integers as our answer. So let's look at an example of what I mean by that. So let's say you have a certain amount of money that you want to allocate for gifts, and you want to allocate that to different family members. So I declare that you have $20 in gift money, and you have 3 family members. So we know that splitting $20 between 3 people is not an integer answer. You're going to get a decimal. 20 divided by 3 is a decimal number. It's going to be 6 point something something something. So when we try to tell the compiler, hey, calculate how much money we want to allocate per person. So we do double average is equal to gift money divided by family members. So it's like, all right, gift money is 20, family members 3. 20 divided by 3. And when it prints it out, we get 6. We know that's wrong. But the reason why the compiler does that is because we're giving it 2 integers. So it assumes that it wants an integer answer. So in that case, we would need to utilize casting to convert one of them into a double. Now you're probably thinking, why don't I just put it as 20.0 instead of 20? That would eliminate the problem. But you don't always get the time or the opportunity to do that. Let's say you're getting user input. you can't just put the 0.0 at the end of that. So you would utilize casting to enable you to do that. And we're going to show you, I'm going to do an example with you that allows us to use casting in conjunction with the scanner class. So to address the problem that we had before, we use casting. So just like the last problem, we have our declaration and then assigned values. We have $20 assigned to gift money, and we have 3 family members. Now, instead of having both of them as integers, one of them gets converted into a double because we tell the compiler to cast it. Cast one of the values to a double, and we do that by utilizing the double casting sequence. So open parentheses, double, close parentheses, and then whatever your variable name is. And then what happens is that 20 now becomes 20.0. All of a sudden, the compiler is like, yo, I'm not going to be dividing integers anymore. I'm dividing doubles. So it promotes all the values to double. So not only does, now that this is 20.0, it converts this into 3.0 automatically and divides it. And that's why when you print out the average, well, we get the more, I guess, exact answer, 6.666667. So let's go to the compiler and test all of these casting demos out. We're in the compiler, and let's convert an integer into a double. So we declare an integer x, and we assign the value 5. Now, I want to put that integer into a double. So we can declare a double, and then we convert the double, or rather we convert the integer into a double by writing this double sequence and then writing the variable that we want to convert. So this is the double sequence, and this tells the compiler that whatever this value is, if it's an integer, convert it into a double. That way, when we print out our double, we should get 5.0. And we get 5.0. Now, what I was saying previously was that this is an example of widening casting. So technically speaking, you don't really have to put this double sequence here, because what the compiler does is that it actually upgrades the answer automatically when you're assigning it to double y. What I mean by that is you don't really need the double sequence here in this specific example. But the reason why we put it in, let's say, later ones is because when you're dividing, it's going to give you an integer answer. So that's why we do it, for the sake of doing it, because it's common practice. And it allows us to not get any problems in our calculations in the future, specifically with something like division. Alrighty, so now let's convert a double into an integer. So double x, I'm going to declare a double x, and I'm going to set the value to 6.9. Now I want to convert 6.9 into an integer, so it's going to become 6 because it cuts off the 0.9. Integer y is equal to x. Now, to convert it into an integer, we have to put the integer casting thing here, the integer sequence. So this tells the compiler, whatever this value is, if it's a double, I want you to cut off the decimal, and I want you to convert it into an integer. And we get 6. And the reason why that we can't do what we did before, where we can just eliminate this, is because this is an example of narrowing casting or downcasting. So you're losing some type of data. So when I try to assign the value 6.9 to integer y, it's not going to compile because we get a lossy conversion. It loses some type of data. So that is why it wouldn't work without converting it into an integer prior to assigning it to an integer variable. Alrighty, so I want you to create a new Java file, and you create a new Java file by going to File, New, and Java. Alright, I want you to write a program that receives user input on how many guests they will have and how much money they have to spend on gifts. Then calculate the average money spent on each person, assuming that all the money is used. So I want you to try it out, experiment with it, pause the video, and we'll discuss the solution. Alrighty, I hope you managed that. Let's get into it. So first we need to declare our class. Public class gift money. And make sure to have your curly brackets. Now we have to declare our main method that I told you to try to memorize. And then have the curly brackets there as well. So the first thing I want to do is import my scanner. So import java.util. Asterisk. This imports all the classes that are in this package, so I don't really have to emphasize that I just want the scanner. Alrighty, so let's declare the scanner. Scanner, my scanner is equal to new scanner system.in. So we declare that we want to utilize a scanner within our program, and then this actually creates the scanner. And we access the scanner by calling it through this name, the identifier. Alright, so let's first tell the user what they should input. So system.out.println, how much money did you budget for gifts? Alrighty, and then we have to declare a variable and then collect that user input. So integer gift money is equal to, we have to access the scanner, so we call it by the identifier, and since we're getting an integer, we utilize the nextInt method, or the nextInt function, and this tells the compiler that whatever the user input, it better be an integer. Now we want to know how many people that they want to spend money they want to spend gifts on, so how much money they want to spend gifts on, so we have to collect how many people they want to. How many people do you want to spend gift money on? And again, we're going to declare an integer and be like people. Access that we're utilizing the scanner, and since it's also an integer, we utilize the nextInt function to say, hey, we want an integer. Now we got to do the calculation. So the calculation is most likely going to give us a double answer. So we're going to be like double average money is equal to, now how do we calculate the average per person? We divide gift money, because that is how much money they have in total, and we divide that by how many people. Now, as we know, these two are integers, so even if it's a decimal answer from our basic math class, the compiler is going to be like, alright, I'm going to return an integer, and then that integer gets assigned into this double, and we do not want that. We want the most specific answer, the one that gives us the correct answer. So we have to convert one of these into a double. And as I said before, right, why can't we just put the 0.0? Well, we can't put the 0.0 in a variable. So we utilize casting. So we tell the compiler we want this variable to become a double. And now gift money is no longer an integer. It is now a double in this scenario. Right? It is still a integer whenever you access it, but just in this sort of line, it's now a double. So now the compiler's like, all right, we have a double, and now I'm probably going to return a double answer. So system.out.println average per person This tells the person that's utilizing our program that this is the money that you spend or the average money you spend per person. And let's add that $sign there. Then we concatenate that with our average money. And there you go. That should be our program. And let's test it out. Save file, obviously. Gift money. Make sure that it's the same name as your class. Alrighty, and let's run it. How much money did you budget for gifts? Alright, I have $20 that I want to budget for gifts. How many people do you want to spend gift money on? I'm going to pick the number 3. The reason why is because I know that 20 divided by 3 is going to give me a decimal answer. Or rather, it should give me a decimal answer, assuming that our program works. So I'm going to enter 3. And it tells me that my average per person is approximately $6.67 per person. I hope that you enjoyed this video on casting, and keep on practicing.